Scaling a PostgreSQL database is essential as your application grows. Without the right strategies in place, performance can suffer, reliability can be impacted, and user experience can decline. Today, we're diving into the best practice for keeping your PostgreSQL database fast, efficient, and scalable as your demand increases. Before we talk about specific scaling strategies, let's look at the key factors that impact PostgreSQL's ability to scale. Understanding these will help you pinpoint bottlenecks and make better decisions. First, consider your workload type. Different strategies apply depending on whether your application is handling OLTP or OLAP workloads. OLTP, or online transaction processing, is write-heavy and requires low latency. Think e-commerce platforms or banking applications. On the other hand, OLAP, or online analytical processing, involves read-heavy queries for reporting and business intelligence, where partitioning and parallel query execution can make a big difference. Another major factor is I/O performance. Your database performance is only as fast as the disk it runs on. Slow disk I/O can become a bottleneck, so using SSDs and regularly monitoring disk usage is key to keeping things running smoothly. Memory utilization is another critical component. PostgreSQL relies heavily on caching, so ensuring you allocate enough memory for shared buffers and work memory will help minimize expensive disk reads and writes. Then there's connection handling. Too many simultaneous connections can overwhelm PostgreSQL's process per connection model. This is where connection poolers like PG Bouncer come in hand. They help manage connections more efficiently and help reduce resource usage. Finally, data partitioning plays a critical role in scalability. Splitting large tables into smaller partitions allows queries to scan only the relevant data, which improves query speed and reduces the index size. This is especially important for applications with time series data or large transactional tables. Once you understand these factors, the next step is choosing between vertical and horizontal scaling. Each approach has its benefits and challenges, and the right choice depends on your application's needs. Vertical scaling, or scaling up, is the simplest option. It involves adding more CPU, RAM, or faster storage to a single server. This can be quick to implement and requires no changes to your application or database architecture. However, it does have its limits. Hardware can only scale so far before it becomes too costly or reaches its capacity. On the other hand, horizontal scaling, also known as scaling out, distributes the workload across multiple machines. This approach provides virtually unlimited scalability and improves fault tolerance, but it introduces a lot of complexity. Strategies like sharding, where data is split across multiple nodes, can improve performance, but require careful design to avoid uneven distribution. Read replication, where data is copied to multiple read-only nodes, helps with read-heavy workloads, but doesn't improve write performance. Choosing between these strategies depends on your workload and growth projections. Sometimes the best approach is a combination of both, and that's where expert guidance like what we provide at Keyhole software can make a difference. Beyond scaling, optimizing queries and indexing is crucial for high-performance applications. Even with the right infrastructure, inefficient queries can slow down your database. Here are some best practices to keep in mind. First, always specify the columns you need instead of using a select star. This reduces unnecessary data retrieval and speeds up query execution. Minimize your nested subqueries. Use joins effectively and limit the amount of data returned by using pagination for large result sets. Filtering and sorting are also key. Apply where clauses early to exclude unnecessary data before processing, and use order by sparingly, since sorting can be resource intensive. Additionally, inner joins typically perform better than outer joins as they reduce the number of rows processed. Indexes are your best friend when it comes to speed. B-tree indexes work well for equality queries, while GIN and GIST indexes are ideal for full text search and complex data types like JSON-B, for example. Regularly monitor your index usage and remove any that aren't helping any performance. A useful tool is the Explain Analyze, which provides insights into query execution plans. It'll help identify slow queries and areas for optimization, whether that's adding missing indexes or adjusting query structures. And finally, don't forget about regular maintenance. PostgreSQL uses multi-version concurrency control, or MVCC, which can cause table bloat over time. Running routine vacuum and analyze operations helps reclaim disk space and ensures the query planner has up-to-date statistics for making smart execution decisions. Scaling a Postgres database isn't just about throwing more hardware at the problem. It requires a combination of smart architecture decisions, query optimizations, and proactive maintenance. By implementing these best practices, you'll ensure your database can handle increasing demand while maintaining top-tier performance. At Keyhole Software, we specialize in crafting tailored scaling strategies that align with your specific needs. Whether you need help implementing vertical or horizontal scaling techniques, optimizing queries, or ensuring your architecture is built for long-term success, we're here to help. If you're facing scaling challenges or want to future-proof your PostgreSQL environment, let's talk. Contact Keyhole Software today, and let's build a scalable, high-performance database together.